This is a video on adding and subtracting radical expressions. So to add or subtract radical expressions, there's really three steps to the approach. The first thing you want to do is simplify each term completely, which really means simplify each radical in the entire expression as much as possible. After that, we want to determine which terms are like radicals. So that means that they would have the exact same root, right? You're taking the same exact root, and the inside, the radicand, would be the same. So they have to have the same root and the same inside of the root. The outside, the coefficient, in terms of variables, would have to be the same. But if there was just a numerical coefficient, then that would just be added or subtracted as normal. So step 3 is combine like radicals by adding or subtracting the coefficients and keeping the radical part of the term the same. So the coefficient will change when you add or subtract, but the part inside the radical will stay the same, similar to how when you add like terms. Alright, so let's take a look at some examples. So if I perform the indicated operation here, so I have 4 radical 5 plus 7 radical 5. Notice that they both are the square root, so they have the same root, and the inside, the radicand, is the same. It's 5 inside the same, is the same inside of both of them. So 4 radical 5 plus 7 radical 5, all you do is add their coefficients. 4 plus 7 gives us 11, and then the radical 5 piece stays the same, similar to how when you add like terms with variables. So the answer here is 11 radical 5. For B here, similar type of problem. We have 9 cubed root of 2 plus 5 cubed root of 2. The cubed root of 2, right, they're both the same root. They both have to be the same root, so they're both the cubed root. That's good. And the inside is 2, so they're like radicals. They have the same inside and the same root. So you add their coefficients, 9 plus 5, which gives us 14. And then the cubed root of 2 just stays the cubed root of 2. For part C, I've got 3 square root of x squared y minus 7 square root of x squared y. So they do have the same root, and they do have the same inside. So they are like radicals as they are, and we could add them together right now if we wanted to. But notice we could actually simplify the inside of each radical term. Remember I mentioned that in my steps, the first one was due to simplify each radical term. And the way we can simplify it is, the square root of an x squared is just going to give us x for each of these. The square root of y has to stay the same. So this is really equal to 3 times x, taking the square root of the x squared, times square root y, minus 7 times the square root of x squared is just x, square root of y stays square root y. So this is going to equal to, now the like radicals are the square root of y. The coefficients are 3x minus 7x. Notice these coefficients are like terms, right? They have the same variable to the same power, so I'm allowed to combine them. So 3x minus 7x gives us a negative 4x. And then the radical piece comes along as square root of y. Let's take a look at some more complex examples. So if we wanted to perform the indicated operation here. For A, we have 3 radical 28 plus radical 64 plus 2 radical 63 minus 12. And remember, our first step was to simplify each term if possible. So here I've got 3 radical 28. Remember, when I'm simplifying a square root, you want the highest factor that's a square root. It's a perfect square for 28. So this will be 3, and then it's going to be the square root of 4 is the highest perfect square factor times 28, or times 4 times 7 gives us 28. All right, so it's 3 square root of 4 times square root of 7. Plus the square root of 64, we know that evaluates nicely to 8. Plus 2 times the square root of 63. We want to break it up to a perfect square factor and a non-perfect square. So this will be the square root of 9 times the square root of 7, because 9 is the highest perfect square factor of 63. And then 12, well, that's just a constant, so it's minus 12 at the end. Simplifying each of these terms now, 3 times the square root of 4 is really 3 times 2 square root of 7. Plus, this still stays plus 8. Plus here I got 2 times the square root of 9, we know simplifies to 3, so this is 3 square root of 7. And then we got minus 12 here. And this is equal to, now you can multiply the coefficient times the coefficient here. So 3 times 2 gives us 6 radical 7 plus 8 plus 2 times 3 gives us another 6 radical 7 minus 12. So this will be equal to, now we're going to combine like terms. In this case, you combine like radicals. So 6 radical 7 plus another 6 radical 7. Remember, you add the coefficients, gives us 12 radical 7. All right, taking care of the radical terms. And then we got a positive 8 minus 12, which makes us minus 4 at the end. And then that's our answer. You can't combine these two terms because 4 doesn't have a radical 7 after it. Remember, they have to have the exact same root. So you can't call this, the common mistake people make is they would call this 8 radical 7, but you can't subtract the 4 away from this because of the root 7 that's attached to that term. Looking at another one down here. Again, we got 2 radical 27 plus 5 radical 48 minus 4 radical 12. Again, we want to simplify all of these radicals, breaking them down to the highest perfect square factor and another factor. So this is going to be 2 times, the square root of 27 is really the square root of 9 times square root of 3. All right, 9 being the perfect square factor, the highest perfect square factor of 27. Plus here we got 5, the square root of 48. The highest perfect square factor of 48 is actually 16. All right, sometimes people make the common mistake of saying 4 because they know 4 is a factor of 48, but you want the highest perfect square factor when you break this down. So square root of 16 times the square root of 3, that's how you get 48, minus 4, and then square root of 12 breaks down to the square root of 4 times the square root of 3, because 4 times 3 gives you 12. 4 is the highest perfect square factor of 12. And now we'll simplify these. So it's going to be 2 times, radical 9 becomes 3, so it's 3 square root 3, plus 5 times radical 16 becomes 4, square root 3. And then we have minus 4 times square root of 4 becomes 2 square root 3. So multiplying these together, 2 times 3 gives us 6 radical 3, plus 5 times 4 gives us 20 radical 3, minus 4 times 2 gives us 8 radical 3. Now notice these all have the same like term, right? The square root of 3 is the radical on all of them. So we can combine all 3 of these. If 2 of them had radical 3s and 1 of them didn't, then the one that didn't would not be able to be combined. But since they all have radical 3, we can actually combine these. So 6 plus 20 would be 26, minus 8 makes this 18 radical 3. All right, let's take a look at a few more examples. So, again, performing indicated operations. So we have the cubed root of 8 plus the cubed root of 54 minus 7 cubed root of 2. Remember, our first step when we're evaluating these is to simplify each radical piece completely. So the cubed root of 8, all right, that's actually a perfect cube. 8 is the same as 2 to the 3rd power, so cubed root of 8 just equals 2. Plus the cubed root of 54, well, you want to break this down now into its highest perfect cube factor, all right, and another factor. So the highest perfect cube that's a factor of 54 would be cubed root of 27 times the cubed root of 2. Minus here we've got 7 times cubed root of 2. 2 is not a perfect cube. It doesn't have any perfect cube factors other than 1, so this is just cubed root of 2. Now we want to combine like radicals here. The cubed root of 2 and the cubed root of 2 are going to be able to combine. This 2 doesn't have a cubed root of 2, so that's going to be a constant. This will be 2 plus the cubed root of 27. That's going to give us our coefficient. Cubed root of 27 is 3. It's going to be 3 cubed root of 2 minus this is 7 cubed root of 2. So this is equal to. Now I can combine the like radicals. So I can combine the two pieces that have cubed root of 2 with them. So 3 minus 7 makes that a negative 4. And then the cubed root of 2 just comes along. This positive 2 in front, I'll just write as plus 2 at the end. You could have also written it as 2 minus 4 cubed root of 2. Just changing the order of the terms. You can't go any further because 2 doesn't have a like radical with the negative 4 cubed root of 2. Part B here has variables in it, and remember your first step is always to simplify the radicals completely. So we'll do that first. So when I'm looking at this and I've got the cubed root of 27x to the 4th y, I'm going to split this up into perfect cube factors and non-perfect cube factors just to start. So 27 is actually a perfect cube in itself. So 27 can be written in the first set of factors, which are all going to be perfect cubes. X to the fourth, the highest perfect cube factor of that would be x to the third. Remember, you want the highest power closest to 4 that's divisible by 3. So it's x to the third. And then there's going to be 1 left over, so we'll put x over into this one. And then here I've got y. Y isn't going to be a perfect cube, doesn't have any perfect cube factors, so y is going to go there. So that's my first term. Minus, for my second term, the cubed root of 64. All right, we're going to do the same thing. Perfect cubes, non-perfect cubes. We're not evaluating yet, but 64 is actually a perfect cube in itself. So I'm going to write 64 in the first set of the perfect cubes. X to the fourth, the highest perfect cube factor is x to the third because it's divisible by 3. Remember, it's to be divisible by the root. And then there'll be 1x left over here. And then we've got y. It doesn't have any perfect cube factors, so it's just going to go into that one. Simplifying this, the cubed root of 27 is going to give us 3x cubed. Cubed root of that is going to be x. And then this is just going to stay as a radical. So it's the cubed root of xy. Minus over here, the cubed root of 64 is going to be 4. The cubed root of x cubed, remember you do 3 divided by 3. You're dividing the exponents here. 3 divided by 3 gives you just a single x to the first power. And this is cubed root of xy. And now you can see that these are like radicals. They're both cube roots, right? So they have the same root and the same radicand. Same thing on the inside, the xy. So the outside is like terms. 3x minus 4x is going to be actually a negative 1x, which I'll also write as negative x. And then this will be the cubed root of xy. All right, taking a look at the next example. It says perform the indicated operation. We got 6 square root of 75 a to the 6b minus 2a square root of 48 a to the 4th b. So the first thing you want to do here is simplify each of the radicals. So these are square roots, so the coefficients can stay in front. So it's going to be 6 in front here. And if I'm simplifying this radical here, I really want to set up a radical with perfect squares and a radical with non-perfect squares. All right, and these are perfect square factors of whatever's on the inside. So the perfect square factors will go in the front. The non-perfect square factors will go in the radical in the back. So 75, the highest perfect square factor of 75 is 25. And then 25 times 3 gives me 75. That's the non-perfect square factor. It goes in the second one. We're just splitting this up. We're not evaluating yet. All right. So we got square root of 25 times square root of 3 would give us 75. For a to the 6th, that is a perfect square because 6 is divisible by 2. It divides evenly by 2. And since with the square root, the way you can tell if a variable is a perfect square is if it's divisible by whatever the root is. So 6 divided by 2. We make that a to the 3rd, but before I do that, let me just write it as a to the 6th here. Just separating it out. A to the 6th is a perfect square. We're going to put it in the first one. And then we got b to the 1st power. It's not a perfect square. It doesn't have any perfect square factors, so we're just going to write it in the second piece. So that's how you're going to rewrite the square root of 75 a to the 6b. All right, we're not evaluating any of the root yet. Minus, we have 2a is the coefficient here, and now I'm going to split up the square root of 48 a to the 4th b into perfect squares and non-perfect square factors. The highest perfect square factor of 48 is 16, and 16 times 3 is the non-perfect square, would give you 48. A to the 4th is a perfect square because it's to an even power, so it's divisible by 2. So we can write that as a to the 4th in the first set of brackets, or first square root symbol, sorry. And then b is not a perfect square. It doesn't have any perfect square factors, so we're going to put the b in the second square root symbol. Now simplifying this, we got 6 times. We're going to simplify just the perfect square piece. Square root of 25 is 5. Square root of a to the 6 is 6 divided by the root, so 6 divided by 2, which makes us a to the 3. And then the square root of 3b still stays on the end here. Minus, this is 2a times square root of 16 is 4. Square root of a to the 4th is a to the 2nd power. All right, and then we got the square root of 3b left over here. You can multiply the coefficients together. So 6 times 5 gives us 30a to the 3rd square root 3b minus, here I've got 2a times 4a squared. So 2 times 4 gives me 8. 8 times a squared makes this a to the 3rd power square root of 3b And now these are like radicals. They have the same root, right? They're both square roots, so the same radicand, same thing on the inside. And the coefficients of these terms, all right, make them like terms, right? A to the third and a to the third are the same, so I'm allowed to combine these. So 30 minus 8 gives us 22. A to the third, a square root of 3b. All right, let's take a look at the next one. All right, looking at the next problem. So looking at this, we've got 7 cubed root of 32x to the 13th y to the 5th plus 5x cubed root of 4x to the 10th y to the 5th. So again, we have to simplify our radicals first. So 7 is a coefficient, will stay in front. I want to set up a radical for perfect cubes and a radical for non-perfect cubes. And I'm splitting up just this the first term, just this term. So 7 stayed in front. I'm splitting this up into perfect cubes and non-perfect cubes. 32 as a perfect cube factor. The highest perfect cube that's a factor of 32 would be 8. The other factor would be 4, because 8 times 4 gives you 32. All right, the highest perfect cube is a factor of x to the 13th. Remember, I need the closest number to 13 that's divisible by 3, but it can't be higher than 13. So this is going to be x to the 12, and then there's 12 there. There's got to be 1 left over here to make x to the 13. And y to the 5th, highest perfect cube factor would be y to the 3rd, right? It's the closest thing to 5, divisible by 3, but not higher than 5. So y to the 3rd. If we need 5 total, there's 3 here, we need 2 left over. Similar here for the second term, will be plus 5. This is just 5x as a coefficient, and now we're going to split this up into perfect cubes and non-perfect cubes. 4 is not a perfect cube and doesn't have any perfect cube factors, so it's just going to go in the second set. X to the 10th is not a perfect cube, but the highest number close to 10 divisible by 3 would be 9, so we put x to the 9 here. And there's 1 left over if we need x to the 10. And we got y to the 5th here. Not a perfect cube because 5 doesn't divide by 3 evenly, but y to the 3rd is the closest power that's divisible by 3 to 5. It doesn't go higher than 5, and then this will be y to the 2nd because you need 5 total, so there's 2 left over. Simplifying this, is going to be 7 times. Now evaluating this first cubed root, remember it's a perfect cube, so it should evaluate nicely. Cubed root of 8 is 2. Cubed root of x to the 12 is x to the 12 divided by 3, which gives us 4. Y to the 3 divided by 3, taking the cubed root of that makes that just y to the 1, so let's write it as y. And this will be the cubed root of 4xy squared. Plus here I have 5x times, remember the first set of values are all perfect cubes, so the cubed root of them should come out nicely. So x to the 9th, taking the cubed root, remember it's 9 divided by 3, divide the exponent. So 9 divided by 3 makes that x to the 3, y to the 3 divided by 3 makes that y. And then we have the cubed root of 4xy squared. These are non-perfect cubes, so they don't simplify. And now we'll just simplify each term before we can combine. 7 times 2 gives us 14. This is going to be x to the 4th y times the cubed root of 4xy squared. Plus here I got 5x times x cubed y. X times x is x to the 4th. So this will be 5x to the 4th y cubed root of 4xy squared. And now these are like cubes. Alright, and they have the same inside, the same radicand, and the same root. Oh. So this is equal to, adding the coefficients, 14 plus 5 gives us 19x to the 4 times y, and then the cubed root of 4xy squared just stays the same. Alright, here are some for you to try on your own.